Carry on with a little bit of the zero-to-quake-3 project today. When did we last stream? That was Thursday. Oh, I didn't even check that off. Okay, so yeah, just to recap, yesterday was kind of the first breakthrough we've had on the stream. Only a small one, but we now have the ability to create a blue screen, which is good because it actually shows that all of the Vulkan stuff that we've been doing is kind of coming together. So we can do rendering now. We just don't have any data to render or any shaders or anything like that. So there's a little bit more work we need to do, but I think now is a good time to start revisiting some of the things that we've been putting off for a while. So like, yeah, we've got best part 1200 lines of code in one file, which I'm a little uncomfortable with that. A lot of this right field stuff that could be better, so we can tidy that up. We're not doing any resource cleanup at all. It's kind of because we just get a blue screen and terminate, but there's some cleanup that we should be doing, so we'll look into that. Triple buffering would be nice. We only have double buffering at the moment. We're also missing, when I think about it, frame fences. We'll get to that later, but basically on some graphics cards we're going to be rendering like shitloads of frames at the same time, which doesn't really make any sense because you can't respond to a frame 20 frames in the future. So it seems quite common to limit it to 2 in-flight frames at once, and you do it with fences. Limit. I realised I think we're missing a check for this. Determine the presentation queue. Yeah, okay, so we're kind of assuming that we're on the same queue for presentation as we are for rendering. That's not necessarily true. So there's some correctness things, but I'd also like to get to having a triangle on screen by the end of the day. So let's see. I'm just going to quickly announce that we are live. And then let's get some work on the go. Cool. So, yeah, let's look at this DSL first, because it's kind of the most important. So what I'm thinking here, actually we'll just start with the one that kind of comes with the library that we've, I kind of overlooked at the start. So it's all hidden all the way down here. But got this Marshall module, which is this new VK data that we've been using so far. Unsafe pointer that we've been using. In fact, there's no other way to get a pointer to things, I don't think, anyway, so we'll use the unsafe one because we have no choice. But what's more interesting anyway is Marshall Create has what I think is a little bit of kind of DSL to tidy some of this stuff up. So let's see. I mean, one thing that's nice is I've mentioned in a previous stream that like we have this pattern of new VK data which gives us a pointer, and then we have to pass that pointer everywhere. Which smells a lot like a reader monad or something like that. So my hunch was to build a reader monad over this, but let's just use what we've been given. And see how this works. Maybe it's not very nice. Maybe we do like it. We'll see. Not too much to worry about there. We can tidy this up. Okay, so it's no longer new VK data, but create VK. So is this thing to combine? I think we do need this because this almost looks like kind of index monad. Like this is like an app operator that just combines 2 effects together. But this changes. Yeah, let's just use that. So now rather than write field, we just do set s type, I believe. So set just takes a value at the value level, but it also needs this fname type to be passed in, and that's the very first argument here. So set s type. You know what, I think I'm going to import that unqualified. We're going to need it. It's a nice way to do this. I think we would actually benefit from a little bit of custom formatting here, which I'm not usually a huge fan of, but hey, I do think it's going to make things a little tidier. Yeah, see something like that. Oops. Oh, I can't type today. Let's get GHCID back up as well. There we go. It's not bad. There's also more that I'm going to be adding into this. I've just realised. How do these get added then? We've got set, at, set str list ref. Probably that. So I think there's actually an export for this string. Luna G standard validation. Let's see if we can find that. Oh, I hate to tell. Yeah, so I agree. It's this tight level monoid type thing. It also, I mean, this app operator that I was talking about before. Let's get this back up. This guy is pretty similar as well to kind of combine or something. Similar to that kind of product presentation of applicatives as a kind of tupling monoid type thing. But yeah, not sure there's much more we can do in terms of syntax other than this. Right, anyway, so yeah, I think there's a actual symbol that we can use instead of a string here, which is just a little bit nicer. Oh no, there's no validation thing, that's a bit annoying. I guess it's in the core. We got constants. Barely anything in here. Let's do it like this for now. Once documentation loads, try another approach. So we're going to have another array. but we don't actually have any extensions. Aha. So apparently I'm like passing an I/O computation to here, which is not correct. And that's obviously not my intention either. Oh man, the type errors you get for this thing are horrible. So this is kind of why I don't like these little like pretend DSLs. Like already you can see like GHC's having a hard time just maintaining formatting and stuff. It'd be nicer if we could just use denotation or something. Let's try just one. Ah, so I think create VK actually pretends to be pure. Yeah. Yeah, that's kind of nice. Like, gotta be convenient to see how much that shoots us in the foot later, but oh, this is beautiful. There's like unsafe IO here, and then we unsafely get a pointer over here. Like, what could possibly go wrong? Oh, hey, Cedric. So we've definitely got a bit of a Vulcan guru with us, so you're going to see me fumbling around a lot. Okay, it's going to be good fun. Well, that's gone well already. Segvault right off the bat. Let's do some solid Haskell debugging. Print statements. Yeah, so I wonder if the garbage collector be coming in first. Let's try inlining this. This is not filling me with joy for this DSL. Maybe we'll roll our own. Oh, I'm pretty good at getting Haskell to... Actually, no, to be fair, I don't get many Haskell segfaults. I do manage to break the compiler quite a lot. So if that's part of my high score, then I'm definitely winning there. Oh, this sucks. Like, it's kind of a nice DSL because it's got like some encoding of the Vulkan spec itself. So here, like, I'm just trying to set two fields of this strut, and it's saying, no, you definitely got to give me enabled extension names. problem is it doesn't actually work. Okay, that gets us a little further. Is there a problem with this? Happy with that. Well, I haven't told it to look at any enabled layers. Hang on a minute, this is a bit suspicious. Oh, I think I must have done a bad job editing this. So we're saying we're going to have like length of needed extensions, enabled extensions, but I didn't pass any in. So I guess that's where our segbolt is, which is probably coming from Vulkan itself. Kind of would have hoped the validation. Well, I guess the validation layer can't pick that up. I gave it a point. It's a garbage memory. I don't know what it's going to do with that. Okay, so so the needed extensions now actually just needs to be a string. Let's get this other one added back in. The problem is needed extensions. Cool. So get needed extensions is giving us pointers, like C-style pointers to strings. Let's do the marshalling there. Cool, that's good, we're back. So is there a way to avoid this unsafe pointer thing? Well, the good news is at least it's not this DSL that I was worried about. Like, that's not the problem. The problem is I just didn't use it properly, which I'm going to have to be careful of. Yeah, there's nothing that like sets a counter around the list at the same time, which kind of could have been nice. Create VK always gives me like a VK create imp or something. Prefer this function to no, but that's something different. Yeah. Okay, this looks like it's the way to do it. So I think I'm going to factor that back out, just keep these definitions small. So, what's this suggestion then of how to format this? Yeah. So, are you having to do this indentation yourself, or are you saying, oh, I guess like the opening bracket's taking care of that for you? I don't know if I've got the same indentation mode that you've got. So I guess you're suggesting it would look something like... Yeah, so I guess you're having to do this yourself, but then after that you don't have to worry about it. So what would that be? 1, 2, 3. Yeah, I think we've got different. Well, one indentation gets me there. And then I'm there. I don't know. We'll leave it how it is. Neither are ideal, but we'll do what we can. So the next thing I want to do as well, as I move along with this, is maybe move some of these things into separate modules. Actually, we'll do that at the end. This pattern shows up a lot in Vulkan programming as well. Like we need to allocate space for create instance to push a result into, and then we just immediately peek that back out. So like we can easily abstract that. We're going to alloc and peek. Maybe something like that. So yeah, I really try and avoid using the dollar operator. So we've got a little helper function. Okay, so I think we've kind of got the framework in place to get this code tidied up, so let's quickly blast through this. Same idea. Despite just saying I hate this Palladium, I'm going to use it again. Okay. Well, kind of wrong there actually. That alloc and peak thing is not quite what we want there, because we're not actually interested in the amount of devices we've got, we're interested in the array that comes out of it. So maybe let's have alloc and peak array. Size the array. Yeah, so it's just alloc array and then peak array. Oh man, Emacs is weird today. Yeah, this is a little cleaner. Yeah, like the reason I can't use alloca and peak here is kind of we're going to reuse the send devices pointer. This is a pattern that seems to show up in Bulk in a couple of places, and I'm not entirely sure. Well, maybe I do abstract that out. Yeah, why not? That's kind of nice. I can type on that later. So now we can just say physical devices, fetch all end pointer. Oops, what am I doing? No, what am I doing? That was fine as it was. Right, cool. There's that alloca and peak type thing again. There is an alternative to read field. That should be get. What about installing smart parens in Emacs? I think I have had it in the past. It just gets a little. In fact, I think I do have it on. One thing that does annoy me is it seems to get confused with pragmas, so I end up with that. So I've always got that trailing bracket, very annoying. So I think that might be coming from smart parens. So this is all about setting. Down here. No pointers, field offsets. Look at all these wonderful types. Yeah, it's just get field. Rather than read field, so we just and that is a pure function. Really? Not a good idea? I guess the idea is once you create one of these things, you really should be mutating it. Which is reasonable actually, there's no like pure or even IO based setters once you've got one of these structures, other than using say pointer. there's that same idea. So yes, it was a good idea that we abstracted this out. And families pointer, pointer. Oh. What's that? Get field. Okay, so that's actually a pure function now, which is kind of nice. I'm going to use the list monad here. I find it a little easier to read. Okay. Oh, we've got a filter here as well. Oh, that's kind of nice. I can just use guard. Bit too much going on there. So this is now, don't need to return that capable thing. Cape. That's a bit nicer. Ah, I've got to do there. Don't need that anymore. Okay, what about let's create logical device. So we'll create K. Okay, how do I set a list of pointers, list of floats? I guess it's set list ref. Yeah, that looks reasonable. Whoa, this is a big one. Yeah, we'll come back to that. Herod's complaining about in a moment. Okay, Alaka and Peak. Cool. Does it still work? Yep. You can't see that because it's on my other monitor, but it is working. Okay, so here's that fetch all idiom again. Surface format count pointer. Oops. Surface formats pointer. Cool. So these now become let bindings. No need to use a pointer on that. Yeah, I'll leave that as it is, I think, for now. What are we doing here? Alec and Peak. Cool. That is a big strut. Yeah, I should probably be using some clever Emacs macros or something. That's definitely more compact and a little easier to scan. Okay. Yeah, so the mic is pretty close and it's a pretty damn loud keyboard as well. If it is insanely loud, let me know and I can try and move it somewhere a little bit nicer. Oh, this is a fetch all idiom. Image count pointer and images pointer. To be fair, I could be doing a lot less typing if Haskell had a half decent automatic formatter as well. But let's not go down that path today. Oops. What are we doing here? Same type of thing for the color attachment reference. Oh yeah, flush lines. That's the one. I could do with binding that to something. Let's do that going forward. There's one that kills lines with a regular expression to get rid of those pointers. Is it flush line? Isn't it? Oh, so you're saying flush lines is the one that I want. Yeah, cool. Can I do that? Nice. Oh, yeah, okay. I should be lazy to do it that way. There's another one that just gets... There's definitely a better way of flushing lines than just that regular expression, I'm sure. Nah, okay. So what regular expression give me? Man, Emacs regular expressions are so weird. But that is much more convenient. Good tip. Oh, I don't want to do that. The good news is I have learnt my lesson now, so yeah, going forwards. Oh, God. Part of the problem is this keyboard doesn't have an escape key, so I have to use Control G to go out of insert mode, but for some reason I have to press it multiple times to get out of insert mode. So that's why I kind of keep making some weird mistakes, but that's just excuses. Right, so what have we got here? Set list ref key color attachments. I think we're almost halfway. Ah, interesting. What's going on here? Cute. Yeah, I do want to do it, don't I? What? I don't know how I've done that. I think we're moving through this at a pretty good rate. I can't see it being too much longer now. The good news is, once I finish this, the next thing that we're going to be doing to get a triangle on screen will involve even more of these things. Unfortunately, latency got the better of you, but you're right. I got the wrong monadic operator. To be fair, I think a lot of the lines that we're reclaiming are just my blank lines from my fairly excessive formatting. But part of the reason I actually do that is with the intention of getting annoyed at it. So I actually really verbosely format my code because it does a really good job of bringing to the surface places where you clearly need to get rid of some duplication or a function's got way too big. And once you do that, I think the excessive white space actually doesn't seem so excessive at all. So just a little aside there. Oh, it wasn't bk create, was it? It's create bk. Ah, is this one? This one might be slightly different then. Oh no. What am I doing here? That is fmap. Oh. Why am I peeking? Try again. That's better. Still working? Yep, good. 80%. Yeah, you're right. This is probably a case of just typing sometimes it's going to be quicker. There's something about just like shuffling stuff around that uses a different part of my brain though. I just kind of switch off and I do a fairly bad job of moving things around, but uh, I think this. No, I'm not going to say it. I was going to say I think this might be the last one, but I bet if I say that it won't be the last one. Nah, that's cool. Just happy to have people engaged. It's a Friday night and you guys are watching me literally move text around, so you have higher expectations than me for what an interesting Friday night is. Yeah, I don't know. That might have been quicker if I had not completely failed to Emacs afterwards. Oh. Yeah, so this is not a good story about functional languages. I don't know, we're kind of seeing some of the benefits, I think, at least of having like IOV explicit, things like this alloca and peak thing, you know, like passing in some higher order functions here that does, it's kind of acting like a bit like a macro. It's quite nice. I kind of throw these things together without really thinking about them. It's just this stuff where I'm basically writing C in Haskell that really sucks. What are you complaining about? Set list ref. Marshall with array and then send it in. Yeah, I'm just going to leave that. There's not much we can do about that. Yeah, I mean, like, this is... The C code isn't going to be much smaller than that. Like, you don't need this line. I guess you need that line as like a variable declaration, and then each of these just becomes strut or s-type equals this. So like that bit's pretty much the same in C and Haskell. This then becomes a little bit more annoying because I basically turn a Haskell list into, I put it onto the heap, get a pointer to that, and then I can give that to Vulkan, whereas in C that's considerably simpler. What we are going to see after this is we're going to do resource management, and I think I'm going to use the managed monad for that, which is kind of cool. And at this point, you're kind of getting out of C and you're starting to write some more Haskell-y like code. We're going to use that for automatic resource collection, resource destruction and garbage collection kind of stuff. Create UK. At least that's my plan. We'll see if it actually works out in practice. My gosh, we are actually done. So that's not bad. I think that's like a net of about 400 lines of code we managed to delete there. Is there any way to initialize those structs like with curly braces in C++? So there isn't really any special syntax that we can use. One thing that is true, however, and you kind of jogged my memory here, is like, so this whole syntax that we're using with that ampersand and the star and create PK is just a domain specific language that comes with this API. But it does track required and optional fields. So I don't know if the notion of like a field with a default is actually in the Vulkan spec. But for example, if I do something like S-type is obviously a required thing, if I take that out, I now get this domain-specific error message, non-optional field S-type of structure is not set. So I could go through these and find the defaults and remove them. So as you said, like pnext is always null. I'm not sure exactly how it's initializing stuff. Let's have a look at that actually. What's handle rem fields? Notify the user. So this is just about providing type errors, I think. And yeah. Hey Adam, yeah, good. You've just missed a huge refactoring session. So you haven't missed much on the stream today. And now we're just looking to see if there's any more kind of useless code we can delete that's just doing something that could be inferred. Oh my gosh, this doesn't look like Haskell at all. You know what, let's try taking some of these out that look like obvious defaults and see what happens. We might be okay. Just check that this actually compiles at the moment. Yep, still good. Validation layer is not throwing anything up either. So, can I take those out? Yeah, so that's annoying. So like, even though pnext is always null, I do actually have to supply it. Flags could go. Things could go. In fact, before I start deleting even more code, I think it's a good time to commit. Cool. So, where were we? Let's find that first create BK. That can go. That can go. We are setting everything there. Oh man, I've got to set enabled layer names, but I don't have to set enabled layer count. That looks a bit suspicious. Yeah. Yeah, I'm not entirely sure I trust leaving some of these out, so I think I'm going to be explicit and just set things. Revert that. It's probably not worth the lines of code to save some strange behaviour if we accidentally end up reading a null pointer when we should have been setting a proper pointer or something like that. So discard those, yes. So I'm going to say that our DSL for building bulk constructs is done. I'm happy with that. Resource cleanup is the next one. So as I've kind of been hinting, my plan was to a little bit. Plan was to use this managed, which is a monad for managed values. Technically, it's the codensity monad if you want to be really fancy about it, but I quite like this library. So the idea is basically you have this monad managed, and you can you create managed values by providing something of this really weird type. And basically, what this is is a way to, well, it's essentially a way to kind of create something but also dispose of it when you're finished. So you would supply it something like with file here, so with file knows how to open foo.txt in read mode and gives you back a file handle, but with file implicitly scopes over the lifetime of that file handle, and it kind of flips things on its side here and pushes that scope into the managed monad itself. So I'm going to have to change a couple of things to do that, one of which is just import it. This might not work as well. I think it will, but it might not. Let's see how it works out in practice. So this is control, monad managed. And we're going to need managed, and we need a way to eliminate that. Just re-enter my development environment there, which is going to pull down this new managed dependency, hopefully. But yeah, in order to use this, some of these things are going to have to change. So create window now becomes, actually, we'll work in the managed monad. This is now managed. And the SDL library gives us a slightly better way of creating windows, which is called with window, which will automatically destroy the window when you leave the function that it's given. So let's see if I can find that in here to show you. No? Maybe it doesn't have with window. It should. Doesn't. Oh, interesting. Okay. We can write that ourselves quite easily though. So with window takes like something to do with the window, some function f. And it's going to create a window. Should I use bracket here? Maybe I should. Whenever, yeah. Okay. I haven't done anything special to get Xmonad not to style that window. I think it's based on the window manager properties that get assigned to the window when SDL creates it. You could also head over to my .charles repository on GitHub. My Xmonad config's up there. Destroy window. How have I not ended up with managed? Ah, okay. Not actually using. Alright, put it in here for now. There's something to do though. Yeah, I know. Like, there's a to-do item to use Cabal called Cabal. I don't know this shallow. I mean, this is from the first stream. We just kind of there's a lot of stream of consciousness into these files. They are not the finished products. They will get tidied up, and I do know better. Okay, good. So we can import the managed monad. Oh. Okay. Right, so this is the kind of idea behind this managed monad. So rather than working with like an IO function that produces a window, what you actually work with are IO functions that basically bracket over a window. So what we've got is this with window function, which is essentially something that's going to take STL window IOA, gives you back the IOA, and like it takes care of creating the window, and when this function terminates, it also destroys the window. So we're basically getting prompt resource cleanup just by our choice of monad and careful use of this managed function. And we can do this for all of these things, like create Vulkan instance should actually basically introduce a scope whereby in that scope we have access to a Vulkan instance, but outside that scope the Vulkan instance is automatically being destroyed for us. So it's the same type of thing, we just have to use managed. We're going to use managed and bracket a lot, so let's do manage bracket, which we have create destroy, manage bracket create destroy. Yeah, worry about these. Oh, I'm going to have to do these errors now. So I like to avoid having to explicitly lift things into monads if possible, so let's just make this one a little bit more polymorphic and say it works over any IO monad. A couple more things. Initialize STL. Oops. Just change all these put stral ends to like be a general log function or something now. So before we move over to this manage monad, I'm going to generalize everything I can into monad IO. So I don't quite get your comment there that I shouldn't be just sticking in loads of lift IOs. Like lift IO over lift IO isn't really going to matter, because that outer lift IO will force the rest of the thing to just be IO, in which case, yeah, I mean, it's unnecessary lift IO, but the GHC inliner will definitely hit that. So it's unnecessary, I agree, but like it's not even going to have a runtime impact at all, even though it would be minor if it did. So I'm not too bothered, but when we introduce this managed monad, I'm going to be going into these things and choosing the managed monad in particular, or maybe something like monad managed, which is a type class, and then I'll try and refine those lift IO users. But yeah, you're right. You're definitely right. I kind of like, this is another example of somewhere that might be nice for like a GHC source plugin, probably a source plugin or something like that. They could just say like, you're already in monad IO here, there's no point lifting IO. That'd be really nice. Just like bash programmers have useless use of cat, we can have useless use of lift IO. In fact, I'm curious. So the GL library and the SDL2 libraries both use monad IO kind of everywhere anyway. I wonder if this guy's doing the same thing. Just take a random module. Is there a function call in this thing? Seems to be lots of structures, lots of patterns. Oh, these look like... Yeah, no, if everything is specialized to IO, that's unfortunate. I might open a bug report on that, or a feature request, I guess, to generalize that. Because then we would have kind of naturally ended up in this situation that we're heading to right now. That is a good idea. I have a suggestion to just install local documentation. In fact, it should really just be a case of it's just that, right? Yeah, that's what you kind of said. Oh wow, I think this is going to build a ton of stuff. It's only going to build a couple of things. I'll leave that going in the background. Twitch is kind of hammering my internet connection. Okay, good. Just in time. Yeah, I don't think you have to grab that path. So we have something like this at Circuit Hub. You can just use run Google now, and you'll just get a local Google server running. Let's have a look. Oh, it's just Google, isn't it? That's on 8080. Oh man, why didn't I do this earlier? That's going to be much nicer to look things up. I guess it's still going to be... Yeah. So the only annoying thing about this local Google server is it's still, like, Chrome isn't happy with local file paths. But right clicking and copying a link is not too bad, I can live with that. Cool. I definitely need to do that in a separate tab. Right, so let's try and do this. Resource management correctly. So create windows, fine. That's now going through the management of transformer. I might actually use monad managed just to generalize that. Oh, cool. I didn't know about that one. So apparently, you know, these links should work. Oh, beautiful. Thanks for that. Problem is, there's too many of us at work just kind of put up with stuff. We don't actually dig into things, find proper solutions. We'll just learn to live with things. So create window, yeah, let's generalize this then to be monad managed. Annoyingly, nothing really uses monad managed. We're going to have to do like a lift operation ourselves. Yeah, oh well. See if we can do that. So we're going to import monad managed, not going to use that. Missing lift IOs. that into the top like that. Got a bit lazy with these ones. I think we're getting a odd problem here with high rank type variables, so let's just bite the bullet and turn on rank and types, give it an explicit type signature. Cool. Do a couple of signatures here. Like that it thinks it could return a completely different array. So we wrote manage bracket so we could simplify this. So let's try and do it over here. So we can create a Vulkan instance. Yeah, nothing wrong with copying a type signature from a warning. You'd expect it to work. Or do you mean my weird AV type signature? When we're done with an instance, okay, so when we're done with it, you have to give it a pointer to allocation callbacks, I think. Let's have a look. VK destroy instance. Needs a VK instance, and oh man, that pointer's in a really awkward place. Cool. So now, because we're using manage bracket, and we're using monad managed, I get the kind of convenience of just doing a normal monadic bind and getting access to a Vulkan VK instance. But this monad managed is also going to kind of keep track of this callback to run at the end, which is going to destroy the instance. And if we got that right, I guess actually, yeah, and we're using bracket as well, so even if I control C this, you're also going to Oops, I've built manage from source, but never mind. It's also going to happen in the case of an exception, which is kind of important. So no matter how the consumer of this VK instance terminates, it's still going to call destroy instance, which is kind of what we want. So there's nothing to... Oh no, there should be something here. How have I spelled suitable wrong twice? Every time I scroll past that, I'm like, that doesn't look right there. To create physical device doesn't... Well, okay, so it doesn't really... You never really create physical devices because that wouldn't make any sense. I can't... I can't change the world. Yeah, so brackets, like you should always be thinking about brackets when you're allocating resources that need some kind of timely cleanup. But just using bracket alone, you end up with like a ton of nesting, and it's like bracket dollar do this, bracket dollar do this, and like it all kind of turns into a bit of a mess if you've got a lot of resources going around. So manage can be a nice way to tidy that up, because we'll see like this code here is verbose but quite nice. Like there's no crazy indentation, it's not all running off the screen. I just like do something, bind it to a variable, do something else, bind it to a variable. It's quite nice. But as we layer in this manage monad, we're also going to get resource deallocation added in without having to change any of that code. So yeah, physical devices, there is no cleanup that we need to do because I can't destroy your physical graphics card. That wouldn't be very nice for me. Find key family index just finds it, so there's nothing that gets allocated there. Create logical device. So logical devices I do need to clean up. So let's manage bracket here. So I guess it's going to be VK destroy device. Yep. Okay, so my problem here is like the thing to manage. Oh no, that is IO. Oh, so Vulkan lets you take full control of the allocator, and that's what these allocation callbacks are for. But if you use a custom allocator with custom allocation callbacks, you have to put the same ones into both of these. So technically, I should like be binding this to a variable and making sure that I pass exactly the same thing. But null pointer is a null pointer. There is only one of them, so I don't think we're going to do any custom memory allocation. Pretty sure Quake-3 has been running for 18 years just fine without it, so I'd be surprised if we need it now. Right, but if I just pass null pointer into all of these allocators, I just get normal malloc behavior, right? Presumably that's by the vendor drivers. I guess the vendor drivers get to choose what their allocation strategy is. Why? What is this complaining about then? Oh, because of the big lift IO at the top, which we don't need anymore. Cool. So we're now destroying our logical device. We create a swap chain, which we should do that. We should manage that. Oops. swap chain KHRA. No, we're going to get the same thing again because we've got a big lift IO up here. So can't do that. Nope, the problem here is I put that in the wrong place. There you go. So that needs a device and a swap chain. It's kind of weird. I feel like if I've already created a swap chain, why do I need to pass the device that it was created with to destroy it? Like, is that not implicitly tied to the swap chain itself? Cool, so that's swap chains with a bit of resource management, get swap chain image. I don't know if I meant to be doing any disposal there, we'll leave that one. Create render paths, we definitely need to manage that. Cool, that's render passes, frame buffers. I think there's one thing that I probably should have mentioned about the technique that we're using here is kind of exactly when these resources are going to be deallocated. And I believe that's going to happen in kind of reverse order when this guy finishes. So for example, if we were to, for example, maybe create something here and then only use it here but never use it anywhere else, that resource is still going to end up staying around until this run manage terminates. So that's something to kind of keep in mind when you're using this technique. If you really, really need prompt resource scopes, then you need to move where that bracketing happens and control that bracketed region as much as possible. And we'll probably kind of do that in our render loop itself. I think our render loop's probably going to have its own allocation scope, which will be like a per frame allocation scope. If we need to create things in a frame, and I'm not sure if we actually do, because kind of the point of Vulkan is we'll push as much of this to be upfront as possible. So for example, our command buffers and stuff are all being allocated outside the frames that we're rendering. But we'll see, we might need to allocate some resources. So what was I doing here? Okay. Destroy frame buffer. Yeah, this is weird that you'd have to pass the device in. So. Create image view sounds like I'm just going to get a guess here. This one needs to have a bit of memory management. Ah, come on, me Max. create command pool. Ah, done it again. Destroy command pool. Just thinking this kind of idea of manage bracket, allocate MP, and a create thing that takes allocation callbacks and has a corresponding destroy. We are repeating that. Maybe all of this would be nice if we just brought that out. Like create, destroy. That is a gnarly type, and that is definitely not the type we want to work with. Oh man, what is this type? So yeah, like the allocation callbacks. See what GHC says about that. Oh, come on. Why can't I? Thank you. Yeah, that's even nicer. So, like, it's really clear how we're pairing things together there. And this, even this create info, like, that's really common as well. So let's do that. Let's just push that into here as well. No, I can't do that, can I? No. Okay, I think I'm going to leave it there. That's probably the sweet spot. Yeah, that's nice. Do allocated command buffers have to be deallocated? Oh, hang on, it's going to be quicker just getting the PDF up, actually. Oh, there's free command buffers, which we should probably be doing as well. This is a little bit different because it doesn't have the custom allocated stuff, so just do this one manually. Token VK free command buffers for a device from a command pool. Just the one, and I need to. Cool. Recording a render pass is just a call to begin render pass. There's nothing to deal with there. Might change that to be with render pass in the future though. Oh, that's annoying. Semaphores don't have custom outlet. Or do they? What? Oh, I just didn't give you the device. Cool. Alright. Happy with all of that. So we've got some resource cleanup in place. That's enough for now. Good, and it all still works. And also, we're at just shy of 900 lines of code, so we're still no need to explicitly. Okay, so yeah, I guess my command buffer has a lifetime that's the same as the command pool, but I'm thinking it might be nice. I don't know how often people create command buffers, or if there would ever be a situation where I might be creating command buffers with a short lifespan from a command pool that has a much longer lifespan. So I'll leave it in there for now anyway. I don't think it does any harm. So yeah, we're just shy of 900 lines of code. We were about 1200 lines of code when we started, and we've now got resource cleanup in there. So that's a pretty nice result. Find out how to correctly use Vulkan Loader. Might defer that to another stream. Nothing too interesting there. I think what would be fun is we actually try and move this project forward a little bit. So we get a triangle on the screen. So like I'm just following the Vulkan tutorial for the most part. And what we don't have, yeah, I'm definitely not that far yet, is anything in this graphics pipeline really. So this is just a kind of intro chapter. We're going to need some shader modules, and we're going to need to define all the fixed function phases of the pipeline, and we're also going to have to build a pipeline as well. I've been doing this tutorial kind of upside down, and I think I'm going to carry on with that, which is kind of like using the final things I want as a forcing function to show me all the things along the way that I need. And that's really in this conclusion here. One thing that we don't have at the moment is a graphics pipeline. So we'll start with that, and then I'm going to follow the pointers along the way back to all of these things like the fixed functions and the shader modules that we need along the way. So let's just do that after all of this stuff's done. We're going to need a logical device, a pipeline cache. We're not using pipeline caches, so that's device. Not going to use a pipeline cache, so we're going to null that. We're going to create one, and we're going to give that create info. Then it takes allocator, callbacks, and pipelines. Callback for destroying it. Just call destroy pipeline with exactly one pipeline and a device. Alright, what does this guy need then? ABK. There's a lot to be aware of when you're using these things, but that's what I'm most interested in. Cool. So P next is going to be null. Flags is a bit mask of a VK pipeline create flag bits. So that's how the pipeline will be generated. I don't think we need to worry about any of those. Now we get on to the juicy stuff. Stages. So the idea here is when you're using Vulkan, your rendering goes through kind of multiple stages. So you first give it some vertices, they go through a vertex shader which works out what their what do they call it, like the device clip space coordinates are. That's going to go through other stages here, like we could do tessellation stages and things like that to add more geometry as a shader stage. We've got rasterization to actually rasterize the triangles into fragments, multi-sampling, and the actual fragment shader itself that works out how we're going to colour things. So we're not interested in much of this at the moment because we're just going to be trying to get a triangle on screen. I believe we've got to have a vertex stage, I think. The stage member of one element must be VK shader stage vertex, but the stage member of each element must not be a compute bit. If it includes tessellation, which it's not going to, it's not going to have a tessellation evaluation stage. Yeah, worry about that later. So, I think we're only going to have one stage here. Oops. Okay, so vertex input state. It was complaining, I wonder how many of these I have to set. Base, pipeline, index. I'm not doing that, so. The index of the subpass in the render pass, we're going to use the only subpass that we have, which has index 0. Render pass is a handle to a render pass object describing the environment in which it will be used. Pipeline must only be used. Interesting. We only have a single render pass at the moment. layout is a description of binding locations used by pipeline and descriptor set. So I think this is about relaying information to shaders. Oh, I see, I've got to create one of these guys. Okay, it's saying perhaps you meant this, even though it looks like exactly what I typed, but obviously I made a typo and I can't bother to look at why. So we're going to need a device. Oh, it doesn't. What's the create info? Here we are. Pipeline layout create info does not have S-type. Yeah, it does. Pipeline layout create info. Oh man. Oh. No. Yeah, I've got to do that on save point thing. Just going to like null everything for now. We'll come back to that as we actually start to fill this information in. Pset layouts. Why do we need that, or have I already used it? That's down here, wasn't it? Oh man, these are some big structures. Here we go. Jeez. So I don't think it really matters what line width is because like we're not rendering on wireframe. Depth by slope factor. We aren't generating shadow maps or anything like that. Just use counterclockwise windings. It's generally pretty sane default these days. Front face. Oh wait. Try. Oh, I don't know. I'm not even going to turn culling on for now anyway, so. VK polygon fill. We want to see full triangles. P input assembly state. Let's have a look at these stages. Ah, okay. Let's just go with main. Now I need a shader module. Do I put vertex bit and fragment bit, or just vertex bit? It's not a mask, is it? Yeah, maybe it is. Let's have a look at the tutorial on that. What are we saying again? P stages. Yeah, so there are two shader stages. I guess one is the vertex and one is the fragment shader. Yeah. Okay. Oops. It's set strut ref. So now I need a shader module for our vertex shader. That needs to be one of those. This is our vertex shader, so it gets that. This is our fragment shader, so it gets this one. Presumably these are going to be like load GLSL type things, or load spur V, or whatever it is. Pipeline vertex input state create info. Oops. Pipeline vertex. I do indeed need both vertex and fragment shaders. Yeah, I was thinking a little loosely at the start. I think we can get away without any of this vertex binding stuff, because we're going to do what the tutorial does and just define the normalized device coordinates in the vertex shader itself. Assembly state create info. We'll use a triangle list for now. I think that is also how triangles laid out in Quake-3 BSPs. Might be a triangle strip. I'm pretty sure it's a triangle list with an index buffer. That is going into P input assembly state. Oh, already got that. Okay, so this now needs to create a shader module. How do we do that? Create a shader module? Cool, create shader module. You got it. device and say create info. What am I doing? Ah. What? I don't think that's the correct rendering. Must be a valid pointer to an array of code size e/4. No. Okay, so I think this is the SPIRV stuff. So this would just take a byte stream. I'm glad you're enjoying the keyboard sound. It's a Ergodox. That's half the keyboard. Other half's over here. Is there an easy way to set? What does it want me to give it? Yeah, code size. Not helpful. Pointer to bytes. Okay. Load. Load shader. Takes a file path. Gives you back a shader module. Data.byteString. Do read file. So how do I feel about Vulkan or OpenGL? I'd say it probably depends on your goal. Like if you're just exploring some space and it's pretty traditional rasterized 3D graphics, maybe starting with OpenGL is going to be a better option. The purpose of this project for me is to learn Vulkan, because I've never really done any Vulkan programming before. I've done quite a bit of OpenGL, and like even though OpenGL can be a bit of a pain in the ass to get a triangle on screen, it's nowhere near the amount of time we've spent on this stream so far just trying to get a triangle. And that's partly because I'm learning what I'm doing at the same time, and we don't have any existing code to fall back on. But I think we're heading to about 9 hours of streaming now, and all we've really managed to do is get a blue window to be displayed. Soon we might have a triangle. So in that sense, Vulkan's going to be a lot slower to get started with. There's fewer resources out there about it as well. Not sure how much of a problem that is. The spec is very detailed. But I'd say like if you have an idea of something you want to build, maybe OpenGL is going to be a better option for now. You can always, if you do things right and OpenGL is just sitting on the fringe of your system, it should be quite easy to swap that out later. But I probably don't have enough information at the moment to truly give you a good opinion as to which I'd choose. I'd just go for OpenGL because it's definitely what I know better than this. Byte string used as len bytes. Yeah, so what I'm thinking in terms of like Haskell specifically is I think because we're actually closer to the machine, it's in an odd way going to work better with a language like Haskell. Just because things are so drastically different when you're working in a functional domain, we quite often want to slice and dice things very differently. So I think being actually closer to the metal is going to let us write really nice high-level things that compile down to very efficient kind of bare metal code. It's just a hunch I have at the moment. But like when we use OpenGL in Haskell, you're very much forced into the OpenGL paradigm, which can be a little difficult to reconcile with Haskell sometimes. Yeah, amusingly, I was watching Handmade Hero 2 nights ago, and he really hates Vulkan. He was really hating on it. So it's a terrible API design, and doesn't see the point of it. Now that Apple has deprecated OpenGL as well, he was like, you should just be writing separate renderers for every platform, and I was like, oh, I don't know about that. So the byte string library is giving me a pointer of chars or cars, or whatever I'm going to call them. I actually need to cast that into word 32s. It's kind of weird that it gave me. Well, it's giving me a C string. Like, yeah. So anyway, it's char star, and I need to cast that. Oh, this is annoying. Okay, actually no, this isn't so annoying. Let's move the manage wrapper to be out here. Okay, we've Got everything there to create a graphics pipeline now. This is going to crash because we haven't got those SPIR-V files around. I may need some help off people to do this. The problem is Vulkan needs bytecode for its shaders, and I don't know how to compile them on Linux. But let's have a look. So shader modules. Just double checking. It looks like this should all be compatible with the tutorial. That's how to open a file. Great, don't worry, I know how to do that. Just don't know if I'm going to be able to get this validator thing. Oh, okay, let's try. Yeah, I know there's GRSL lang validator, whatever I just said. The problem is my Linux distribution, Nixos, is kind of, I don't know, fairly niche, I suppose you could say. So, don't have a lot of packages for some of this stuff, but apparently I do have this one. What are you on about? You just said it was there. Oh, not validator. Yeah, so in terms of shaders, I'm actually just going to grab exactly what they've got. That's not so important. What's that? The frag and the vertex shader. Just because I kind of want to limit what could go wrong to the just our Vulkan code and not the shaders themselves. So, shader.frac. What am I doing? Shader.bird. How does this go away then? Oh, big V creates SPIR-V binary under Vulkan semantics. That's given us vert.spv and frag.spv. Let's use those then. That wasn't too hard. I thought that was going to be a bit of a stopping point. That's okay. That just means we didn't put the Vulkan loader on our LD library path, which is this to-do item here, to do this properly. Which is probably just linking against it. Right, so VK create graphics pipeline FP create and post rasterization state false. Well, we didn't want that to be false. P rasterization state. That was a rasterizer discard enable. Do I want to enable discarding? No. Oh wait, but that is VK false, so probably that by default. I guess that's the kind of double negative there. It's just so a 0 here in memory is the correct default. Okay, so P viewport state isn't being set, and that's what it's complaining about really. validation layer is absolutely killer. Can't get over how good it is. Going to be using one viewport, which I think means we have to use one scissor region as well. Must match the number of viewports, yeah, that makes sense. Cool, so viewports is an array of VK viewport structures. Oh, it hasn't complained that I haven't set that, that's kind of surprising. Viewports. And scissors, which is just going to be what are you on about? I think that might be because this viewport thing hasn't been defined. So a VK viewport is it a pointer? Yeah. X, Y, width, height, min, max. X, Y, width, height. What's that? Min depth, max depth. That was a really weird way to type that. So we're going to be passing in an extent. Yeah, let's say with a width and a height. Just so we render to the full size of our swap chain surface. I don't know, 1 to 100 for a depth buffer, doesn't really matter right now. There's an extent. Okay, you expected. Oh wait, a viewport. Do viewports go between 0 and 1? No, okay, you do have to cast it. Oh, and the depth is 0 to 1. I guess I'm thinking more in terms of setting up a projection matrix. I need to cast it to a float, so yeah, come on. Cool. Let's get a scissor region as well. The scissor region has an offset and an extent. Okay, so that's our viewports and our scissor regions all set up now. Multi-sample state must not be null. Multi-sample is one word. Multi-sample state. Multi-sample state. That's the only one I was wanting to grab. So I haven't set the sample shading. That should be 1. It's, well, optional, but it's really not optional according to this. Sterilization samples, that's presumably, okay. Line width must be 1. Okay, chill out. P color blend state is null when rasterization is able to add to subpass users color attachments. If the rasterization Discord member is false and subpass uses color attachments, P color blend state must be a pointer. Let's set that one then. Which makes sense. So this is the instructions on how to blend the output of the fragment shader with the attached color buffer, I think. We just kind of, so we could do like alpha blending and stuff like that, but we just want to basically override whatever's in the color buffer. No, this thing doesn't need S-type. It does, there we go. Blend constants. This one I am going to copy from the tutorial because it's not here. Am I looking at the wrong thing? There we go. Set at okay. I'm just going to copy from the tutorial the correct way to get this color attachment set up. Blend enable, yes. Blend op add. color attachment count of 1, which doesn't match blend state attachment count. Thanks for that. There are no problems with our graphics pipeline now. Shall we double check against what they've done? So let's just compare against the fixed function pipeline from the tutorial. So the vertex input structure they use. 0, 0, and that's what we're getting from the defaults. The assembly state they're using a triangle-less, and they turned restart off, but I was going to get turned off by default. Set the viewpoint sensor up the same way. Rasterizer, okay, so depth clamp enabler got set to false. We're not even specifying it, so I think that's okay. Discard is set to false, which is polygon mode is fill. Line width of 1. They have culling on, but I want to turn it off anyway. They use clockwise. Let's go clockwise just to be on the safe side to match their vertex shader. Depth bias is false. And then 0, 0, 0, perfect there. Yep, cool. I think we did that pipeline layout as well, didn't we? Yeah. So I think we might get a triangle very shortly. I think all we've got to do is, yeah, like literally these two things. Find the pipeline and do a draw call. I am expecting to put these two commands in, still have a blank screen, have no validation errors, and be very, very confused as to why nothing's happening. But fingers crossed. So this is going to happen right after we begin the render pass. So that's happening up here. Into this command buffer. Would help if we created the pipeline before the command buffers, so we can use it. And then welcome VK raw. Into our command buffer 3, 1, 0, 0. Magic constants. I'm gonna have to lift that from the IO monad into our special managed monad. Oops. All good. Alright, moment of truth. That's exactly what I said. Okay. So, no validation errors. no triangle. Not too bothered with all of that. So what's really problematic now is render doc doesn't work either. So it would be nice to just say capture, or at least it didn't work last night. What working directory are you in? Okay, well let's... So the blue screen is coming from my, what do you call it? Yeah, my render pass. One thing I haven't got is a subpass dependency. I don't know if that's important here. So my render pass has a clear value count of 1 and its clear value is to clear the screen with blue. So I do, and that's in record render pass, so I do command begin vk cmd begin render pass, and then right after that I'm doing bind pipeline and draw and finish. So we're all okay with that. Yeah, so we haven't got a subpass dependency set up, so let's try that. And that goes into the render pass. Yank all of that out for now. Oh, actually, does that? Well, I think that goes okay into the actual creation of the render pass. So what could be happening is we could be trying to draw at the wrong time, basically, and if we have this subpass dependency, we get a bit of synchronization as to when Vulkan is going to actually do the drawing. Oh, I just realised to change my window layout. Does the validator automatically validate the sphere V? I don't actually know. No, I had no idea about that. I imagine what's going to happen is when you're going to run through GLSL lang validator, like hints kind of in the name, I guess that does the validation. Yeah, feels about this painful as X11 development. I don't know why I'm doing this to myself. This is my idea of fun as well. I think the precedence of that operator is confusing us. Oh no, I just haven't noticed those yet. Okay, so we've got a subpass dependency now. Of course I didn't actually run it. Oh, come on. Okay, I'm going to take a quick break, a second, just grab a drink, make a cup of tea, and then we'll see what the hell's going on here. So I'll be back shortly. Whoops, not that one. That's... There we go. Okay. Let's see if we can work out what the heck's going on here. We're going to try render doc again, won't we? I have no idea what that means. So our command buffer is definitely getting submitted, otherwise we would just have a blank screen. Because the command buffer contains the call to the render pass. Well, that's just going to end up like failing to run because we don't signal or semaphore and all sorts of stuff. Just trying it with the correct semaphores. Oh. I'd imagine a black screen here. Well, but no transitions happening, so yeah. So yeah, our swap chain images are getting transitioned correctly, and that's all stuff that happens by the render pass. Must be saying in our graphics pipeline then. Let's try and match this up a bit more one for one with the tutorial. That's how to write vertex shaders. Don't care about that. I imagine this create shader module thing isn't some weird like asynchronous call that's ending up reading this pointer when this scope has been left. That'd be quite surprising, so I think we can assume that's not the case. So I think that's okay. We're checking it as well for VK success and stuff. It's all good. Shader stage creation. Vertex shader and fragment shader, vertex shader, fragment shader. VK shader stage vertex bit. You set the module. The P name is just main. Yep. So that's all correct. You do the same fragment shader, fragment bit, and main. Yep. That looks correct. Vertex input. So S type 0 binding description count. Yeah, nothing interesting there. No, I guess they set that, so let's try setting that as well. Although I think that's exactly what the default is. Our viewport is 0, 0, width height 0, 1. Our scissor region is 0, 0, swap chain extent. There we have viewport count 1, scissor count 1, viewport and scissor, so that's fine. So do set depth clamp enabled to false, and I don't have that. It was complaining that that was the case here, but we'll put it in anyway. Polygon mode fill. Line width has to be 1. Cull mode. Maybe it's. Maybe we've got cull mode enabled. Nah, cull mode none would be the default. Depth bias enable. Then they all get set to 0. What's my colour right mask? In the attachment in my pipeline, you mean? Where do you set the attachments on a graphics pipeline? Looking at VK pipeline color band state. Yeah. Yeah, we copied that one for one. Did I maybe miss a line? I think I did. Yeah, you're right. Huh. Oh, yeah, there's a lot going on here. I put that in the wrong one. Yeah. Thing that goes in P attachments, so obviously it's attachment state. This one. Alright, that was definitely missing. Fingers crossed. Oh, I was so hopeful. Okay, damn. I really hope it isn't the fact that whenever this thing starts it says warning, Intel Haswell implementation is like incomplete. I figured it was capable of rendering a triangle, but I guess when it comes to implementing a Vulkan specification, if you can render a triangle you can probably do pretty much everything. Let's look through this again. We'll go back to multi-sampling first. So min sample shading was 1. It just takes from a shop. Sample shading enable was false. Rasterization samples count 1 bit. Sample mask is null pointer alpha. These are all false, so like they're all default, so that's fine. If this is no, I'll go back and check the creation of my render pass and see if we've got anything wrong there. So here we've got color component R bit, G bit, D bit, A bit. Blend enable. Ah! It's me assuming that it was meant to be true. Oh, I think it said if blend enable is true, then the original color passes through. So maybe I misread that. Nope. Not that either. So source dust color blend factor 1 0. Where have I got this from? Oh, I just didn't copy the alpha blending settings. Okay. Would that do it? Source alpha 1 minus source alpha. Yeah. Maybe? Right, so blend enable false, source color blend factor 1, 0, color blend op add 1, 0, alpha blend op add. Yeah, that's all as it was. I guess let's make sure we got this other one correct then. They're all zeros. We reference our color blend attachment. Attachment count is 1. Logic op enable false. That looks fine. Pipeline layout's fine. That's all there. So, was our render pass wrong? Count 1 bit, load up clear, store up store, don't care, undefined, yep. 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 Pipeline bind point graphics, color attachment 1. Render pass, attachment count 1, subpass count 1, and then we've got the dependency that we've just added in as well, so that's all fine as well. That looks problematic. I think I was only running a single stage. Oh, please tell me it wasn't just that. Oh my god, are you kidding me? Oh, success! I should be happy. That is exhausting. So, yeah, we just messed around for, I don't know, the best part of half an hour, wondering why we didn't have a triangle on the screen, and it was simply because I wrote 1 here instead of 2, which meant that we would only go through the vertex shader stage and not the fragment shader stage. So, I'm definitely going to have a to-do item to, oops, not those lines, these lines, like tidy this up. There is an implicit dependency here between this number and these things, and I've got it wrong one too many times now. So I think in the next stream, let's try and work out if we can come up with a nice way to factor that out. But I'm pretty happy with that. That's good. Cool. We can check that guy off. Is it here? I thought we had one here saying render a triangle. Oh well, we've done something that we weren't even meant to do. That's going to be, oops, not refactoring. Progress. Done. Yeah. So. Factor out and setting the correctness. It's always off by one, I agree. Computers are just out to troll me every possible opportunity they get. Cool, I'm pretty happy with that. So we've got more than we ever had before with less code than we had at the end of the last stream, so this is looking really quite nice. Also, one thing I want to do, which we might be able to do tomorrow, is just a trivial refactoring. Like right now, it's kind of okay for where we've been so far. Everything is just dumped into one huge file. I'd like to start splitting that out a little bit. We could have like a physical device module, logical device module, shader module, render pass module, graphics pipeline module, all of that. Like all of these Vulkan objects, I feel should probably just be in their own separate module for a little bit quicker compilation times. And just a bit more organisation, because it's getting quite hard just scrolling around this, looking at what the hell's going on and what this file is actually responsible for. But anyway, it's enough rambling from me. I'm going to wrap the stream up there. Cheers for joining us. It's been quite a long one, but we've got a lot done today. And I think what we're going to focus on in terms of features for the next stream, which will probably be Sunday, sometime on Sunday, is moving this vertex data out of the vertex shader itself and into proper vertex buffer that's controlled by host memory. So cheers for joining, guys. Have a good one. Catch you on the next stream.